Hey guys, welcome to my YouTube channel. So let's get started and we're going to talk about proportional tables. So what we talked about was proportional tables is a table that consists only of equivalent ratios. So the first thing that we had discussed was in a table, what we usually look at is like the ratios from side to side. So if you think about it, it's like 1 to 2, 2 to 4, 3 to 6, 1 to 3, 2 to 6, 3/9. Now, in the 7th grade, we write our ratios as fractions. And so what we typically do is we look at the ratios as y over x. So if I want to figure out if a table is proportional, what I have to do is see, are all of these ratios equivalent to the same number? Now the reason why we do it this way, instead of just practicing like multiplying from x to y, is because sometimes in 7th grade we're going to be dealing with fractions and it's harder to figure out what number multiplied by x gives me y. So here's what I need you guys to do. In your notebook, what I have is you have example 1 and example 2. So what I want you to do is to quickly pause the video if you need to and write down this table. So x to y, 1 to 2, 2 to 4, 3 to 6, which is what we have. And example 2 is 1 to 3, 2 to 6, and 3 to 9. So here's how I want you to show your work. Now I know that a lot of you kind of already know this, but we need to practice how we are going to show our work when we have proportional tables. So if I want to figure out if this table is proportional for example 1, and I'm going to just zoom in here, the first thing we do is we usually look at our ratios as y over x, okay? That's usually what we do. So that's what we're going to practice. So what I'm going to do is I'm going to be like, okay, so my first ratio is y is 2 and x is 1. So I'm going to put 2 over 1. And 2 over 1 honestly equals 2, right? 2 over 1 is just 2. So that equals 2. Okay, so my next ratio, so this is going to be ratio 1. My next ratio is ratio 2. So we're going to do y over x, and we just do this just to like get into the habit of it. And then I'm going to do 4 over 2. So that's going to equal 4 over 2, because again, we look at it from side to side. And that equals also. Now, before we like discuss this, a fraction is literally division. You could just divide. And I'm not sure if you guys know this, but if you look at the division sign, for example, the division sign is literally a fraction and the dots are just in place of numbers. So really what this means is just 4 divided by 2, which also equals 2, or we could write 2 over 1 here. Okay, now my last ratio, I have ratio 3 here. This is going to give me 6 over 3. So we have y over x. That equals 6 over 3. 6 divided by 3 also gives me 2 over 1. So all of these are equivalent to 2, which means yes, this table is proportional. So what we could do is the same thing, on the other side, for example 2. And again, I do know that you guys know how to do this. I know Ms. Nagib had taught you this, but for me, it's just to make sure that you show your work correctly once the tables get actually harder to figure out, because we're going to deal with tables with fractions. So the first thing is ratio 1. Again, we're going to do y over x. And again, make sure that you write down as I write down. So that equals, here we go again, I have 3 over 1. And 3 over 1, that just equals 3. 3 divided by 1. Ratio 2, we have 6 divided by 2, so we're going to do y over x equals 6 over 2. 6 divided by 2, that gives me also 3, or 3 over 1. They're the same, they're equivalent. And ratio 3, so we're going to do y over x. Again, this is just for habit. We have, here we have y, 9, over 3, which is my x, And that also 9 divided by 3 gives me 3 over 1. So if you look at this, both tables are proportional, and the reason why is because both tables have equivalent ratios. So example 1 is proportional because all ratios are equivalent to 2. And table 2 is proportional because all ratios are equivalent to 3. And you'll notice that if I look at my x, every time I multiply my x with my y, or I multiply x with 2 to give me y. And what you notice is that your constant, the number you're always multiplying by, is the number that all ratios are equal to. But we are going to make sure to test out each ratio to make sure they're equivalent.